Hello, Spark fans, and welcome to another Advancing Spark. So last week was all a bit crazy. We had the thing called SQLBits, which is one of the biggest data conferences in Europe, and it's all focused on Microsoft data and looking at Azure and looking at all that kind of crazy stuff. So I had a couple of sessions there talking about Databricks, Delta, the new Synapse Spark engine, and all of that kind of stuff. And I had loads and loads of Q&A. Loads of questions of people going, how does that work? What should you do in that scenario? What should we do there? And I thought what would be quite good is if I take some of the questions and just run through some of the answers as a bit of a permanent record here. So, load of Q&A based around Delta, these ones. I've got a load more Q&A that I'll do in some next videos. But for now, let's have a look at a few questions. As always, don't forget to like and subscribe if the video is useful. And if you've got a load of Q&A, feel free to put it in the comments and we'll see about getting to it. Okay, so question number one. If I'm using a data lake, does that mean I don't need a data warehouse? And this is one of the biggest, common, most fundamental questions that we see. As lakes get more and more popular, as we keep hearing about this thing called the lake house, then people are saying, is this an alternative? We don't need Kimball and warehouses and star schemes anymore. Everything's a lake. And it's an interesting question, right? So, yes, you still need the concept of a warehouse. You 100% need some kind of fairly formal, managed, governed reporting data model that you use to serve data to the business. The business need reliable information to make decisions on. So there is still absolutely 100% a business case for some kind of warehouse. Now, does that warehouse need to be a separate relational engine is an entirely different question. So if your idea of a data warehouse is it is physically a database with this structure and these settings, then we can question it and go, maybe not. Maybe we don't need that anymore. But if the question is, do we need a governed, auditable, regulated data model from which we can serve the business the data? Hey, yes, absolutely 100% we need that kind of thing. Regulation's not going away. Making fiscal reporting's not going away. Making decisions based on the actual hard fact performance of your business is not going away. And we still need that kind of stuff. Now, the reason that this is at all in question is basically there's a bit of a race between vendors to try and be the one platform people can use for everything. I think in academia, it's the unified analytics platform. That's the goal people are trying to aim for, which is I want to be able to do lakey stuff. I want to be flexible. I want to be able to really elastically scale and be cheap and distributed. And I want to use kind of real elastic compute. But also, I want to be governed and have a known fixed schema and auditable and backed up and recoverable and all that kind of stuff. So people saying lakes are good for some stuff, warehouses are good for some other stuff. Databricks have been putting more and more things via Delta, which actually brings a load of those governance, a load of those auditing, a load of those kind of good transactional consistency features into the lake. So the lake is moving a little bit more to be able to do the warehouse things. So you can say, well, maybe I don't need a separate relational engine. I can put it in the lake. Conversely, things like SQL Server, certainly big data clusters, has its own Spark engine, and it's kind of growing that way. And so a lot of database engines are growing more lake kind of capabilities. A lot of lake style technology are growing more database things, and we're all heading in the same direction. Eventually, 100%, we will just have one system. One thing that can do lakey bits, it can do governance bits, and you're all fine in the middle. For now, we've been using a lot of Delta to try and do that data lakehouse stuff, and it's getting there. It's not perfect yet. The SQL environment isn't fully in the state that hardcore SQL analyst would want it to be in. It's getting there, but it's not there yet. For now, you still need a warehouse. Where you put that warehouse, we'll see, and that's going to change over the next 6 months at least anyway. Okay. If Delta leaves a lot of redundant files, does it slow down a lake over time? And it's a good question, right? So the way Delta's working is if I've got 10 files, and I write an update that just changes 1 or 2 records across those 10 files, I'm going to make a complete new copy of those 10 files that have the new changes in there. I'm going to logically mark the old ones as deleted. Now, if I'm doing that a lot, I'm making lots of small changes, I'm going to take full copies of my data constantly, and I'm going to have a huge amount of redundant, logically deleted Parquet files that's just littering my lake. Now, if I was doing a lot of work via directory scanning, that would slow everything down. You think, as the number of files in there gets more and more and more, if I'm dealing with millions of records, millions of files, or even hundreds of thousands of files, that's like a huge, big directory listing job. But honestly, that's not going to affect things here. So because we're reading the transaction log, and that's providing physical pointers to the files that we need, it's no longer a list out the directory structure and read in all these files. It's now I'm going to give you a separate list of files to go and get. So the redundant files we don't really even see because we've got direct pointers to the actual files. So no, it's not going to slow things down as the number of files increases as long as they are redundant. Now, if your actual data set is made up of hundreds, thousands of small files, yes, that slows things down. That is not a good pattern. It's the small files problem. We want to try and avoid it. But redundant files shouldn't be an issue. In terms of speed, obviously they have an issue in terms of cost. You want to vacuum that. You want to decide how long you want to keep those copies, but shouldn't have a performance problem. Okay, do I ever bother registering tables with Hive? Now, it really surprised me when this came up. And actually, I will be honest, we didn't at first. So when we first started using Spark and Databricks and all that kind of stuff, we kind of didn't really get a lot of the uses of Hive. We didn't kind of use it heavily because most of our interactions as engineers was coming from metadata driven. So we just check, we'd have a process that would automatically look in our config metadata, pull out the location in the lake it should be looking at and kind of build up that folder structure and query it. So there's no need for us to have a table registered because we'd always just have programmatically be rummaging around in the lake and finding the right stuff. But the moment you take that lake and you try and put it to the end user, business community, any kind of analyst, then the Hive process makes so much more sense, especially if we're talking JDBC. So if we're saying to Power BI or Tableau or any other reporting tool, hey, go and connect to Databricks and kind of query it and bring back some data, you have to have registered those tables with Hive. Hive becomes incredibly important in surfacing and sharing the data that you've got in your lake out with the wider community. So yes, 100%, everything that we register in the lake, we put into Hive as long as it's a consistent model. So if you talk about the layers of your lake, if saying we call it raw, base, enriched, you might see bronze, silver, gold from Databricks. You might see, raw, cleaning, warehouse, whatever. The zones of your lake, the earliest zone, that kind of unclean, I've not done anything with this yet data, we don't tend to register with Hive because it's not consistent. It might have corrupted records. It might have completely different shapes. It might not be accessible by Hive. So that kind of first layer we don't tend to because it's not really the kind of thing you expose to SQL analysts anyway. But then as soon as you're in your kind of validated standardized layer, then it should be a known fixed managed structure, which gets 100% registered with Hive. When you're in your curated zone and you've kind of, you've shaped your data, you've built a data model, it might be star schemas, it might be flat reporting tables, whatever. Yes, 100% that should be in Hive. So we use Hive a lot, but never as managed tables. Never as the format where the data is held inside Databricks, because you want it always to be your data's in the lake, where we can have Active Directory control, where we've got control of our data. We can see it by other things. Power BI data flows can talk to it. Data Factory can talk to it. We want to make sure that our data is held in the lake. But still, as long as you're using unmanaged tables in Hive, then that is the way forward. Okay, what do we have next? So if I use Z ordering, do I need to partition? So with partitioning, I'm trying to optimize for partition pruning. Basically, I want to tell Spark, if I'm querying on a certain value, don't bother reading these other files. Now, if I'm using optimize and I've Z ordered, what I'm doing is I'm putting my data down in such a way to encourage it not to read certain files. They're both trying to do the same thing. They're trying to minimize the amount of data that I need to read off disk at query time to try and make things faster. It's like makes sense. And yeah, so if I'm doing one, why would I do the other? And it's a really, really, really good question. I was like, I guess this is a good point. And it mainly comes down to the cardinality of the columns that you're trying to use. So if you've got relatively few things, and that's anywhere between 5 to 20, 30, then partitioning, 100% partition makes a lot of sense. If we're talking about real high cardinality values, you've got thousands, hundreds of thousands, you do not want to partition by that because you'll be breaking your data down into two small things and also listing out how many, partition discovery when you query and say what partitions are. It's going to take ages because you're going to have so many of them. So it comes down to the cardinality of the fields that you're trying to optimize. So low cardinality, partitioning makes sense, and then it's just automatically picked up by Hive, and that's great. High cardinality, because of the co-location, that it does. You can have this kind of, I've got values from 0 to 20 million, 100 million, whatever. And actually, well, I'm going to take those ones and plug into that file, those ones into, and it makes sense. It's almost a bit like bucketing in terms of how it actually sort of decides to group that together. So that's it. For me, that's the answer. Should I use one or the other? Kind of should use both, to be honest. The nice thing about Z ordering is that it's kind of an async job. So I can write my data down and I have to know what partitions I'm using at the moment I write my data down. And then I can go back and I can Z order it by different things kind of offline. I can run it as an offline optimized job, do my file compaction at the same time, create my nice ordered files that are going to be optimized for certain query types. And I can change that actually. So I can Z order on different files afterwards and kind of restructure how I'm doing that without having to change my partitioning structure. So there's kind of like a little bit of how many things are you trying to partition on or Z order on, and how likely are you to change it? It's my kind of balancing act. Generally, I always partition first. Partitioning is the default, the de facto, and then I Z order if I really need to optimize, and if I've got certain things, I try to add on top of that partitioning to try and make it work better. And it's all about file sizing inside there. So the reason, there's two reasons that over partitioning is bad. One, just reading out all the different partitions. And two, if you have too granular a partition, the file inside is going to be tiny. Whereas optimize, at least, it's going to get it to a certain amount of size and then go, right, okay, these are good chunks of data to have, and then Z order with inside it. So yeah, it's a balancing act, depends on your data. The consulting answer, it depends. All right, how often do you need to run the optimize command? So optimize is going to do that thing of file compaction as we just saw Z ordering. And it's how often does your data change? So you can optimize every time you update it. You can just say every time I finish writing my data down to disk, run an optimize. It's going to look at all the data and any new data will kind of bring back in and crunch up. Do you need to do that? It kind of depends on how often people are querying your data and how changed it is from its previous state. So for us, normally it's kind of like we fit into a weekly maintenance cycle, just optimize it at some point. The nice thing with optimize, you don't have to run it as an offline job. It's not go wait to the weekend, do it on a Sunday when no one's in the office, run all your optimize, and then kind of, not going to disrupt anyone. Because actually the way Delta works is that it can be running an optimized job and people are querying the data. And while that optimized job's still in progress, they'll just get the current set. And it's only when it's finished optimizing and it's updated the trans log, the next query that comes in will see that, see the updated transaction log, and go hit the newly optimized files. So you can be doing it whilst people are querying it. If people are trying to write to the data at the same time and you've got lots of concurrent writes going on, leave optimized until a kind of a slightly downtime and kind of it's not all that stuff going on. So it depends how often you're updating. You don't want to update. You don't want to be writing into that table at the same time you're optimizing. Try and avoid that if you can. The queuing is not amazing currently. But if you're uploading it in kind of hourly batches, daily batches, then actually you can run optimize on a daily basis without disrupting many people, and it'll keep it nice and freshly optimized. If your update is only updating one or two files, maybe it's not worth doing it. Maybe just do it weekly and it's fine. It's, for me, kind of the best way for people coming from the SQL background is it's a bit like defragging an index, right? So the more you change it, the more fragmented that index gets, the more often you actually need to run and defrag it. It's just kind of the same. The more often you're updating your table, the more likely you are to get lots of small files, the more likely you are to get fragmentation of your data across all these small files, the more often you should be running optimized to then come back and clean it up. But kind of up to you. Depends on volatility, depends on update cadence, all of that stuff. Okay. Is Scala faster than Python and Spark? It's the age-old question because it's so confusing, all the different messages around there. And the answer is largely no, with caveats. So back in the early days of Spark, before we had the data frame API come in, then yes, 100% Scala was faster than Python. If you wrote Python or PySpark, it was going to go slower because currently Spark is Java-based. Spark is Java-based, it runs inside a thing called a JVM, the Java Virtual Machine. And if you try and run Python inside a JVM, it's going to go no and have to go outside that JVM. So you get the kind of horrible interop of sending data back and forth. However, from Spark 2, I think it was, kind of onwards, you've got the data frame API. So anything you were doing, which is spark.read.csv, and you bring some data in, and then you do data frame dot, I don't know, group by aggregate, all that kind of stuff, that's all the data frame API. And what that does is it takes whatever command you're giving it, whether that's Scala or Python or R or .NET these days, and it puts it through the thing called the Catalyst engine. Now that turns whatever you've done into a logical query plan that it executes in Java bytecode. So essentially, there's zero difference. No matter what language you use at the top, the same things get spat out at the bottom, and you can test that. You can pull out the explain plan from doing a load of data frame stuff in Scala, load in Python, load in R, and it'll push out the exact same explain plan. So as long as you're using the data frame API, there is zero difference between using Scala, Python, R, .NET, or even SQL. SQL goes through the same engine and results in the same stuff. So technically, no, Scala's not faster than Python as long as you're using the data frame API. Now, the moment you write a UDF to a scalar style function that is going to execute this separate function for each row in your data frame, then that's going to tank performance. It's going to go outside the JVM. You've got a few things like pandas UDFs, vectorized UDFs, which make it more efficient, but it's still going outside that JVM. So be a little bit careful. There's some scenarios, some stuff you can do when you're not purely using the data frame API that is going to go outside and is going to slow things down. The majority of stuff, you'll be fine. Okay, for now. Because obviously Databricks are working. They announced this thing called the Delta engine with the Photon engine built in. This is a big shift because they've basically rewritten the entire thing to be C++ based, not Java based. So it's not going to run inside a JVM anymore, meaning all those things about Python's slower in that case, R's slower in that case, but most of it's okay as long as you use data frames, might all be going away anyway, because you're not going to have this same interop. Now, I don't know how that's going to work yet. I'm super excited to try and get my hands on it. But even that advice of they're the same, except for these scenarios, those scenarios might be going away too. So we will see, keep an eye on that. For now, as long as you're using data frame, it doesn't matter which language you use. Okay, and finally, how do you get started with Databricks, Spark, and data engineering? So if you're currently like an on-prem ETL developer, if you're building warehouses, if you're you've never even touched this and you're looking outside going, I don't even know where to start. Delta, Z ordering, what's all this about? So there's loads and loads of really good resources. There's some really, really good books. So I'll pop some links to some of the best books down below, but you've got the definitive guide to Spark by Matej Zaharia and Bill Chambers is very, very good. Can be a little heavy, but really, really good. There's the new Learning Spark book by a lot of the Databricks dev advocates. Really, really good. There's a lot of training out there. So find a good YouTube channel and then come and just, again, keep up with it, get the cadence, try and practice some stuff. Databricks have a ton of self-paced training. You need to pay for it, but it's actually very good quality. Lots of notebooks to flow through. You can go and have a play with it. Biggest recommendation, two things. One, there's an Azure free trial. So you can go on to Azure, you get 30 days with, I think, $150, $100, and you can just have a play around with some stuff. If you keep your Databricks cluster super small, you can spin up a cluster and a small lake and have a play with some stuff with £100, £100, and you'll get a load of stuff. You can try and start working with it. But if you want to kind of have an ongoing thing of just trying out lots of different Python notebooks and just trying to teach yourself some of these languages, then you've got the Databricks Community Edition, and that's just free. And it's like a single node Spark cluster. You can never do anything big on it. Never put production data on there. But if you want to have a play around and teach yourself some stuff, then that is a great resource to try and learn. And my final thing is, it's really hard to learn if you don't have an objective. If you don't have a thing you're trying to achieve, it's really, really hard to keep motivated and actually build something and keep going and building and building and building. It's always like, do a little bit, read a bit and go, hey, yeah, okay. At least for me, that's how I learn. I learn by having a problem and banging my head against it into the evening hours. There's a thing called Advent of Code, which is a fantastic resource for, essentially, it's the nerdiest Christmas known to man, but it's great. And every year they release a set of coding problems, and there's one released today, and there's 25 leading up to Christmas, so you can spend your December being a nerd. Now, all these problems are still up there from the past few years. And the way I I love to learn a new language is to say, this year I'm going to do it in Python. This year I'm going to do it in Scala. This year I'm going to do it in R. And some of the problems you'll be like, that's perfect. This language is designed for that. Some you'll be like, oh God, I'm going to have to walk around and bend over backwards to try and get it to fit. But that's great because it's a challenge that you're trying to get through. You're trying to push yourself on. And it's nice to have that objective to keep working on. So absolutely 100%, if you want to learn Spark and Databricks and all that kind of stuff, start off learning Python. It's the easiest and more approachable and most commonly used, like 80% of usage or something crazy like that is now Python in Spark. So it's the way forward. Pick up something like the Databricks Community Edition, pick up Advent of Code, ignore the fact it's talking about elves and Santa and whatnot, and then try and work through some of those coding dojo problems in Python, in a notebook, and just see how far you get. Keep challenging yourself next week, going to do the next one, the next one, the next one. And before you know it, you'll be a Spark whiz. All right, so that is our Q&A from SQLBits, and hopefully some of those questions are good and interesting. And if you have your own, don't forget to drop them down in the comments, and I'll do another Q&A soon. All right, thanks for watching, and catch you next time.